it turned at 3, so that means it must have an even multiplicity. So I might try 3 a couple of times, leaving me with this one value that is very close to 0. Like I said, please do not just write answers down, justify them. So this is where our friend synthetic division comes into play. So I'm thinking -2, well, I know -2 works, but I'm going to put it on the shelf. I do not have to fill in any zeros. I do not have to rearrange the order. So let's go ahead and see what we've got here. I drop the 7, that multiplies to a -14. Add that up, and I believe that is -43. Multiply by -2, and that's a positive 86. Add that up, and is that going to be 59? I believe. Multiply that out, that's going to be -118. And that's going to produce, oh, this isn't working here. I must have made a mistake somewhere along the way. Can somebody identify what that mistake might have been? Apologize for that. Times -2, 86. I was well off here. I didn't carry my 1. Apologies there. All right. So that is going to be -138. So there's our -9 to +18. All right. Blame it on the sickness, I guess. Apologies, guys. All right. So we got a remainder of 0, which doesn't shock us. Now we're going to put the number 3 on the shelf. Again, I'm going to put it off of this 3rd degree because remember, we started 4th. We divided out a factor, so we're down to a 3rd degree. Still not the best. All right. So bring the 7 down. That should be 21. That's going to be -22. That would be -66, which should leave us with 3, 9, and 0. Okay. Now I've got 2 options here. I know that it turned at 3, so I need another one of those. Or I also know that this is a 2nd degree polynomial. And indeed it does factor. So if we multiply 7x squared with 7 and x, 3 I'm going to put across here. So that'll make a 21, and the 1 here will make 1, but I'm going to go double negatives. So x minus 3 again is another factor. That's why it happened twice. Remember the other 0 that happened close to 0? Well, it must have been 1/7, which is close to 0. Now take a look at your P's and Q's to maybe justify that in your head. Is 1 a factor of 18? Yes. Is 7 a factor of 7? So 1/7 does seem like a rational 0. Okay? So in the end, these are the following okay? Those are your following linear factors. Again, if I multiply those out, I will get back to that original function. And my complete list of zeros is 1/7, 3, 3, and -2. Just for clarification, if in these factors you want to write it as x minus 3 quantity squared, you can. Okay? And if you don't want to list this extra 3, you don't have to. I like to just to note that I've got all 4 of them. Okay? So I hope that one helped. Let's try another problem similar to this. Okay? The next one we're going to go after is going to be f of x equals 7x to the 4th minus 32x cubed plus 20x squared minus 160x minus 75. Okay, so again, when we look at this particular problem, we should first note that we have a 4th degree polynomial function, so we need 4 We need 4 factors, we need 4 zeros that we're going to go after in the complex number system. Again, note your P's and your Q's. This would be a pretty extensive list because there's many factors to 75, although there are not many factors to 7. Still keep that in mind, okay? So, if we go after our function, I'm going to just take our old one out. Let's go ahead and put our new one in. 7x to the 4th minus 32x cubed plus 20x squared minus 160x minus 75. Okay? So I'm going to graph. I should have probably gone to a standard window. So I'll go zoom 6. I forgot that I was zoomed that way. Well, so it appears like we only crossed twice. 1, 2, 3, 4, maybe 5. Keep that in mind. That would actually flow because 5 is a factor of 75 and 1 is a factor of 7. This one back here is somewhere between 0 and -1. So first off, I'm going to just calculate a particular value. Let's go with 5 and double check that yes it is. So I'm good to go on that one. Like I said, it's somewhere between 0 and 1, and if that's rational, well, we got to think about how we could get between 0 and -1. This is where you play your cards right, because I think if you go to the 0 feature and you go left bound, let's see here. Sorry, I can't lift that up. So I'm going to go well left of this. I'm going to get as close to that as I potentially can. I'm at 0 at -75. There we go. So I'm below it. I'm basically to the left of it. I'm going to go one more just to make sure. I'm going to come to the right and I'm just going to hit enter. Now, if you remember back before, we might look at this and say, okay, there's probably no reason for me to round it. Do I think this is some kind of crazy square root of a number? Well, I want you to think about this. What number, what factor of this in the denominator could help create that? If you're thinking between 1 and 7, that 7's the only one, you would be correct. What are some factors of this? Well, you could maybe do -1/7, what do you got? 3/7. You could go -5/7. Those might be your potential possibilities. But see, this is where you can play the P's and the Q's to your favor and go back to value and say, okay, I'm going to give -1/7 a shot. Nope, I don't believe that is correct. How about -3/7? Whoops. And that's what we were looking for, okay? So technology is great, but it's not going to give you a nice fraction like that, because in no way were you going to put that on the shelf and divide it out, because that's a rounded value. That's an exact value, okay? So now, if we think about it, we've got 2 of them. So we can get this down to a quadratic if we hope, okay? So first off, let's go ahead and put, maybe I'll put -3/7 on the shelf real quick. We've got 7, -32, 20, -160, and -75, okay? Drop the 7. -3/7 times 7 should be -3, which would add up to -35. -3/7 times -35, well, negative times negative is a positive. 7 goes into 35 5 times 3 is 15. I'm back at 35 again. This time it's going to be a -15, which would be a -175. Negative times negative is a positive. Let's double check. 175 divided by 7 is 25 times 3, 75. So not a shocker. We knew that that was going to be a remainder of 0. Now we'll put 5 on the shelf and work ourselves down one more time. So that's 7. That becomes 35. 0. That becomes 35. And 35 times 5 should be 175. So now if you look at this, you've got second degree. 7x squared, no linear term, plus 35. I'm going to set this equal to 0 because I'm going to go after my zeros first. I can divide everything by 7, and then what you'll notice is you get x squared plus 5 equals 0. Well, if you subtract 5, in the past we wouldn't be able to square root this. We will now. Do not forget plus or minus. Now the square root of negative 5. I don't know 5. I don't know factors of 5, so it'll stay. But the negative can come out as a I. Do not put it in front of the plus or minus. It's still a factor of the square root of 5, so it goes right next to it as a multiplier. So my complete list of zeros now, all 4 of them, 5, negative 3/7, plus or minus I root 5. Now be careful on how you actually write your factors out. Remember, your factors need to multiply back to this original. This original does not have any fractions in it. This is the one that I'm a little bit worried about, how you write it. Most people write x minus 5. What I wouldn't do is write it as x plus 3/7 because I don't believe using that multiplier will get you back to the other one. What you should write it as is 7x plus 3. Remember we talked about you can write the factors without the fractions if you're careful about it. Okay. On the other end, you can go x minus I root 5 and x plus I square root 5. Again, as weird as this sounds, if you multiply that back out, you should get back to the original function. But hopefully you see how I did use the calculator and the p's and the q's to help produce this. That could come up quite a bit, so be careful with it. Okay? All right. The other type of problem that I want to come across with you is looking at a problem in which you are given a 0. Okay? I think you might have had that over the weekend. And it might have been a problem like, okay, here's a function, x to the 4th minus 10x squared minus 16x plus 5. And you're going to be given the 0 at negative 2 plus I. Well, you should know that there's another 0 basically. So it's been gifted to you that the other one should be its complex conjugate, negative 2 minus I. All right? Now you've got a couple of options here. This is a number. Okay, this is a 0. So this could be put on the shelf and you could do synthetic division with it. It does become a bit hairy. You could then take your result, which would drop it to a 3rd degree, and divide this out synthetically, which again, it'll work out nice in the end, but the multiplication, the adding the columns in the middle might be a little bit tough. What I might do is actually take and realize that this is how you would normally say that you got your zeros. X equals negative 2 plus or minus I. At that point, what you can do is kind of like we've talked about before. Remember, I is just a radical. So if we want to get rid of the radical, which is I, we can isolate it by adding the 2 over and then squaring both sides. Again, you should become well versed in squaring a binomial, x squared plus 4x plus 4. The plus or minus disappear based off the square, and we remember I squared is negative 1. If you move that 1 over through addition, that's what your polynomial would be that gives you those 2. With this single one, I know most people don't like it as much, but you could go ahead and long divide. I'm going to leave a space for that cube term in case it kind of pops up. Okay. So x squared into x to the 4th, x squared, back multiply, x4, 4x cubed, plus 5x squared, add the opposite. you get negative 4x cubed minus 15x squared. I'm going to bring down the 16x, minus 16x.